Welcome back, nerds. Let's go get after this thing, huh? Let's do another example. This time we're asking, what curve is represented by the following parametric equations? So I broke it down as to x is equal to some constant a times cosine of t. And let's just define a, and let's just say, just to, let's cover our ass. Let's say that a is a positive number. So we have some positive coefficient on cosine of t, and then we have y is equal to, we got that same coefficient, that same a, that positive number times sine of t. And now, let's not have an initial point and a terminal point. Let's just make it go on forever, we'll restrict it after this. We'll do another problem so you can kind of see how that works as well. Now, if we want to graph this thing up, we're going to need to maybe play around with it and find some sort of relation we can put together. So if you see some trig in here, come on, trig. Isn't there some famous thing? I swear there's something famous, like the Pythagorean theorem. But not the Pythagorean theorem, not that a squared plus b squared equals c squared, but sine squared plus cosine squared equals 1. I think that we know that might be able to come up with something that's going to work well for us, because I don't think this is what we're going to put together. I don't believe it's going to be a function. I mean, x is a function, y is a function. When we put it all together, I don't think this parametric equation is going to be it. So let's just play a game before we graph it up. So off on the side, let's take our x is equal to a times cosine of t, and let's divide the a over to the other side, and we'll get x over a is equal to cosine of t. Looks like cost, huh? That's why I wrote it with a parenthesis at the beginning. And now we'll say y is equal to a times sine of t. Let's divide that a over, and we get the y over a is equal to sine of t. Well, we have to have some sort of relation to put all that shit together. And we know something with sines and cosines. So let's first write it in. So this is just popping out of nowhere, right? Just poof, here it comes. We're like, well, sine squared of t plus cosine squared of t is equal to 1. That's true for any value that you're going to pop into there. Cool. So why don't we, instead of writing in those sines and cosines, do you mind if we just write what it's equal to? And instead of writing that in, I think we have, it's right here. We're going to put in our x over a and our y equals a right into here and here, huh? So we're just going to pop those into a quick little substitution. Oops. Quick little substitution, and I think we're going to be off and running. We're going to get x over a, and we're going to get y over a. And then once we square it up, we get x squared over a squared plus y squared over a squared is equal to 1. If we multiply the a squared over the other side, we see that this is just a circle centered at the origin with a radius of a. Well, shit, we can graph this. Huh? This is no big deal. Let's just graph it in. So it's going to be some sort of circle. So let me draw in some shitty circle. Look at that, some shitty circle, huh? With a and an a, and this one's got to be negative a and negative a, right? Some circle goes around, circle. Shit, what's the orientation though? Can we tell what direction we're moving here? Shit. Well, let's try something. Why don't we just plug in a value of t? I think that might help us out. But let's choose wisely though. So let's start with t equals 0, and then let's 1. Would we use 1? That's an easy number. Everybody knows sine of 1. Yeah, I doubt that. So why don't we not use 1? Why don't we use something that works well with trig, like, I don't know, pi over 2. Cool, so then we can go see what our x and our y value is. So when we pop that thing in, we're going to say, all right, well, cool. X is equal to a times cosine of 0. And then our y is equal to a times sine of 0. So that's, cosine of 0 is 1, so that's a comma, sine of 0 is 0, so that's a comma 0. So we're right here. That's the beginning one. All right, now let's plug it in for x is equal to a times cosine of pi over 2. And then we'll look at y is equal to a times sine of pi over 2. And we're like, all right, So our x value is going to be cosine of any odd multiple of pi over 2 is always equal to 0. So that's 0, comma. And then we have a times sine of pi over 2. Sine of pi over 2 is just equal to 1. So we got 0, comma 1. Hey, we figured out the orientation. And you see how it doesn't really matter? It doesn't actually matter if we go from negative infinity to infinity, because it's a circle. It's just a circle. Yeah. So there we go. So we can change. So when you see curves, parametric equations, and you got sines and cosines, why don't we set that bad boy up? Why don't we put it into the idea of sine squared plus cosine squared equals 1? Now, we could have played the same game and actually given it some sort of restrictions. We would have got to the same spot here if we would have actually gone through and changed this. And just been 0 up to 2 pi. We would have actually been, right there. We would have been good. We would have got the same circle, except we would have terminated. We would have started and stopped at that same black point. I'm making nice and big right now. That would have been our big difference. So we want to be able to pay attention to that stuff too. So look at example 3 in your textbook after this one. See if you can't run that thing through. These are the same sort of concepts. That's on page 641. So until next time.